Okay, so going through a few examples from the same worksheet because they come, oops, they're come, wait, whoa. Oh, because I'm on them. Because they come as a group, right? The carboxylic acid is basically like the base compound with the carboxyl group. So you're looking for C double bond O and an OH. When you replace, and of course you got the R group on the other side, that's the carboxylic acids. Esters are when you replace the hydrogen from the hydroxyl. So you've got C double bond O, single bond O, and then R prime, because the hydrocarbon chain on the right-hand side of the oxygen might be different than the hydrocarbon chain that's represented by the letter R. And then amides, of course, are when you replace the entire the entire hydroxyl group with an amino. Okay, so let me try to go through a couple of examples of this. I'll do number 3. Trans-butanoic acid. Okay, again, you have to look at it as like a recipe on what the compound is made of. So you start by identifying the ending to know what kind of compound you're dealing with. So you know this is a carboxylic acid because it ends with oic acid. Then you have to identify how many carbons are in that chain. And the prefix but tells you that it's 4. So I go 1, 2, 3, 4. The last thing on that chain is a hydroxyl group. So I put my double bond O there. So that is butanoic acid, but I've got but-2-enoic acid. Ene is a double bond. The 2 means that it's on number 2. Don't forget that we start with 1 here and 2. So between carbons number 2 and 3 is my double bond. So I draw that here. And it says trans. So let me get rid of my 2 there. Oops. I have too much. Okay. And because there's no alkyl groups here, I'm just going to use hydrogen. And trans is opposite sides. So I put a hydrogen here, hydrogen there, and then I can complete my double bonds there. Okay. That's trans-butanoic acid. All right, let's do 14. So methyl prop-2-inoate. All right, O8 is an ester. That means that you're going to have an alkyl group that has replaced the hydrogen from the carboxylic acid. So I have to identify how many carbons are in the overall, what do you call it? The parent compound that would be the carboxylic acid. So prop is 3. So I go 1, 2, 3. And then I'm going to do, here's my oxygen. There's my double bond O. And then I have something on the other side of that. And that's my methyl group. So then I do CH3 here. And then I've got 2-ine, which means on number 2, I have a triple bond. And again, this counts as number 1, and then 2, and then 3. So between carbons number 2 and 3, I've got a triple bond. So I'm going to do 1 on this side, grab that, and 1 on the other side. There you go. And finally, do an example of an amide. Let's do 2,2-dibromopropanamide. Again, amide, that means that you've got a carboxyl group where you've taken off the hydroxyl and you've added an amino group, which is NH2. And then you have to identify how many carbons you're going to make your parent carbon, your parent compound. There you go. So prop is 3, 1, 2, 3. I've got my double bond O here, and then at the end, NH2. That makes it propanamide. And then I have to add my 2,2-dibromo. Again, this counts as number 1. This counts as number 2. So I put it like doot doot. And don't forget your bromines. Oops. Okay. Now, naming. Let's do this one. Again, identify the functional group. Here, you can see in this worksheet, sometimes they put it at the front, sometimes at the back, but don't forget they're mirror images. You can just flip it around. So this is always what you're going to look for. So that is a carboxylic acid. So we're going to start by counting from 1, 2, 3, 4, 5, 6. 6 is hex. It is a carboxylic acid, so it's hexanoic acid. Make sure there's a space there. And they have made it a point to put hydrogens in this compound because, oops, I missed something. The double bond there. Let me move that. Okay, so it's hex and it's oic acid, but now I have to account for the double bond here. Okay, so again, start counting at 1 at the carboxyl group, 2, 3. So it's hex 3-enoic acid. But again, what I was going for at the end, they've made it a point to add hydrogens. They're on opposite sides. So it's trans hex 3-enoic acid. Here we go. Do 13. Now we've got double bond O and an oxygen there, and then something else on the other side. This is an ester. So again, we have to identify how many carbons come before. So this is our original carboxyl group. So that means it's methyl. Remember, the thing that comes on the other side of the oxygen that's in the chain is the alkyl group. So this is methyl. And then how many here? We've got 1, 2 carbons. 2 is F. So it's ethanoate. Methylethanoate. And here we have nitrogen and a double bond that says amide. So we're going to identify, starting from here, how many carbons are there? 1, 2, 3, 4. 4 is bute. So we've got butanamide. I'll have to look up if butamide is also, but I don't think so. Put that in brackets. Right. And then we have to identify the alkyl group that is on the nitrogen. That's methyl. But we also have to have capital N because the methyl group is on the nitrogen, not on the bute part of the compound.